Okay, so for my PhD I worked up at SAMS in the northwest of Scotland in Oban, and I was looking at the diel vertical migration of copepods during the polar night, which is a period of time in the winter where the sun doesn't rise above the horizon for over 24 hours. Diel vertical migration is an adaptive response performed by zooplankton and other animals all over the world, which sees them rising to the surface during the hours of darkness to feed on the phytoplankton layers. As the sun rises, they can be seen, and so they're subject to the threat of visual predation, and they sink down en masse as a community to refuge at depth where they can't be seen anymore. As the sun sets, they rise back to the surface to feed, and this happens every single night over and over again right across the planet. So the Arctic's a difficult place to research in the winter. It's cold, dark, and it's icy. People generally don't like going there very much, so we use a kind of remote sensing called acoustics, and so we put instruments in the water column, usually around September, and they send out an acoustic signal, and using that acoustic signal we can look at how much zooplankton's in the water. We leave the instruments there for 11 to 12 months at a time, come back and recover them, and set them up and put them out again for the next year. So we have year-long data despite not having to go to the Arctic that frequently. The data from these instruments tells us about the zooplankton in the water column and how much zooplankton is there. So we get data about every 20 minutes and at a 4-metre depth resolution in the top 100 metres of the water column. So we can see on a kind of a grid how much zooplankton is at any one space and time. So it was always assumed that every single individual would go into this hibernation or diapause where they sink down to depth and spend the winter just using up their energy reserves. But the research we found shows that this isn't always the case, and that at least some of the population remains active and continues to migrate right throughout the polar night. During the polar night, there is no solar signal for the zooplankton to respond to, but they must be responding to something. And we find that right in the depths of winter, the zooplankton are actually responding to the moon. So as the full moon rises every 30 days or so, the zooplankton are moving out of the surface and aggregating at about 50 metres to avoid those illuminated surface layers. The polar summers, or the midnight sun, which is the opposite of the polar night, this period of continuous light, is the complete opposite in some ways. So zooplankton are still migrating, they're still doing this diel vertical migration, but there's no good time to surface. There's no optimal time to be at the top of the water column, and so they do it randomly. So you see that individuals are just foraging as and when required and going to the surface, and then coming back down as quickly as possible to get out of that risky layer. These copepods in the Arctic Ocean sit right in the middle of a very complex food web, and they're really important for energy transfer. So they're eating this very rich phytoplankton, converting into fats, into lipids, which then feeds the fish, the polar cod, which eventually feeds the whales, the entire Arctic food web. And so understanding what these little critters are doing right throughout the winter is really important to understand the entire ecosystem as a whole. So the next step is to start using mathematical modelling approaches to really understand what drives these copepod communities and the likely things that are going to change in the future when we talk about a changing Arctic in terms of warming oceans and reducing sea ice, and to think about where the Arctic might be in 10, 20 or more years' time.